Okay, we're going to be trying out the Cavendish experiment here. I've been letting the torsion balance come to rest over the course of about 24 hours now. Even with that amount of time, I think just from the air circulation from the heating and cooling system, I've still seen a small amount of motion here. So in the last about 10 minutes, I've seen this end move from here over to here. So that's probably about 10 degrees in 10 minutes. I'm going to let this, I'm going to just gently touch this and try and bring it to rest and observe for another couple of minutes. And then whichever direction I see it moving, I'm going to put the bowling balls that are my other masses on the opposite side as that, just so we can verify that there actually is a change in direction, a change in the direction of the acceleration of these things as they rotate. I don't think we're going to be able to get it to a position where they're totally stopped initially. So this seems like the best way that we can still verify that there is some force from gravity between the masses I have on the ends of this meter stick and the bowling balls that I'm going to put in place. So very gently, I'm going to be just trying to stop any motion that we have in there, just a tiny, tiny force. I'll mark where it is right now. Whichever direction I see it move in. After this, I'm going to put the bowling balls on the other side. No, actually, I'm going to try this again. I think I gave it a little bit too much force, even with just that very gentle touch. I see it already moving quite a bit. Let's check that one more time. Looks like that's moving just very slightly, if at all, right now. I can't see any motion. So we'll let that go for a minute, see which direction it's moving, and then put the bowling balls on the opposite side. It looks like in the time that we've let it go, it's moved from here over this way, so it's rotating counterclockwise when viewed from above. So I'm going to put the bowling balls in place on this side and that side over there, try and pull it back clockwise, and we'll see if we can get some noticeable acceleration in that direction. So it looks like we've had our first contact between the masses at the end of the ruler, the meter stick, and the bowling balls. So that's pretty exciting. We did see that motion toward the bowling balls then. Now there is still the question of where that equilibrium position was for the string. It didn't occur to me until just now, but when I marked the spot that it had started at and noticed that it had rotated this way, that could have been an effect of the velocity that I gave it initially. It may not have been accelerating that way. Maybe it would have rotated back this way on its own. So for that, we'll have to go to the video and see if we can observe some acceleration in this direction, or whether that was just my initial velocity. But right now, it looks like a successful test and a successful replication of the Cavendish experiment. After viewing the video, I'm really happy with the results. When I went back and looked at this, after I last touched the torsion balance, this end was moving this direction, so it was rotating clockwise. But on its own, it came to a stop and started rotating back this direction. So we must be really close to the equilibrium position on this right now. So when we started it, it was over this way, to this side of the equilibrium position, and still moving this direction. When we put the bowling balls on there, it turned around, which it would have done anyway to get back to its equilibrium position, but it went way beyond where it had gone the first time. So regardless of which direction it was moving when I put the bowling balls in there, we can see there was some clear effect of the force of gravity from those bowling balls, pulling it much, much farther than it would have gone just due to its own oscillations. So again, this is a really nice example of the force from gravity between two very small objects. A good replication of the Cavendish experiment.